accidents. Okay, so the industry employs about 10% of the working population, but it accounts for about 30% of all occupational fatal injuries, occupational fatalities. Okay, so that's very disproportionate. Okay, so here are some stats from the UK. So in 2022, 2023, the P means provisional. So they need to maybe do some checks before they can finally confirm what the number of cases are, what the number of cases is. Okay, so there are about 45 fatal injuries in UK in 2022, 2023. So average over this period is about 37. And most of the fatal injuries come from fall from height. So I'm sure it's similar to other countries. Working at height, it's very dangerous. I'm sure that will be not surprising. That shouldn't be surprising for you. So over half of the fatal injuries were as a result of people falling from height. So work at height is a very hazardous activity. Okay. So in terms of non-fatal injuries, so there were about 53,000 of them, okay, over a 3-year period, 2020, 2020, 21, 2022, 2023. And here are the things that accounted for them. So we have slip, trips, fall on the same level, fall from height, okay, and other things, okay. But that's a very huge number, okay, 53,000, really high. In terms of illnesses, about 69,000 work-related ill health, okay, cases, okay. But the majority of them, we can see that they are from musculoskeletal disorders. So things like people having, pains, in their backs, pains in their body, and so on and so forth. So it accounts for over half, but then there are other ill health conditions, stress, depression, anxiety, and others. But 69,000, that's a lot. Okay, and this it's dated now, but what I wanted to show you, it's the trend. Okay, and you see that consistently over the years, consistently, construction has recorded the largest number of fatal injuries over 1974 to roughly 2020, 2013, 2014. So there were times manufacturing tops, okay, but you see that construction, beats several times. It has, it's been the worst. But the positive thing is that the trend is a downward trend. So we've been seeing improvement over the years, which is on the positive side. Okay, which on the positive side. Okay. And again, in terms of historical performance, this looks at the health side of things. So this box, the looks like the bluish box shows construction, and this one shows all industries combined. Okay, so it's interesting seeing that if you put all industries together and you compare all industries combined with construction, construction has the worst work-related illness record. So that was from 2001, 2002, all the way to 2013, 2014. Things may probably be better when you compare construction with all other industries. But from the previous slide, you saw that having 69,000 ill health cases is still, quite a huge number, okay, for our industry. So clearly, in terms of safety, that is injuries to people, construction is dangerous. In terms of ill health, construction is also a dangerous industry. So now let's move outside the UK and look at what's happening in other parts of the world. So this is, I got this from the Eurostat. That's as at the time I think that was last year. That was what they had. They may have updated their database, but looking at this trend, it tells you that construction, has historically, has had the worst health and safety performance, okay, compared to other sectors like manufacturing and agriculture, okay. And then if you look at the US, so data I got from the US up to 2019, you see construction recording the largest number of fatal injuries. So that's construction, transport, agriculture, government and other things. Okay, so construction is dangerous, one of the most dangerous sectors, in the US as well. So in 2019, they had over 1,000 fatal injuries all across US. But well, you can say that US is a big country, has 50 states, and so it's not surprising that they have a lot of fatal injuries, but this number is still a lot. Okay, over 1,000 people. Okay, now let's look at other countries. So data I got from Vietnam as of 2013, they talked about construction accounted for about 34%, okay, of fatal injuries. Okay, and then globally, this is what the International Labour Organization says about construction. So this uh, material is dated 2015. So they said that construction accounts for over 1,000, so over 1,000 workers die on sites every year in construction, all over the world, and that's about 30%. Okay, that's about 30%. That's about 30% of all fatal injuries, okay, worldwide. But the interesting thing is that it's not even. So in industrialized countries, so construction workers are 3 to 4 more times likely to die than workers in other sectors. But in developing countries, construction workers are 3 to 6 times more likely to die, okay, from accidents at work compared to workers in other sectors. So clearly, whether developing country or developed country, okay, construction is a hazardous environment to work in. Okay. So still, okay, putting this global statistics into perspective. So for example, 100,000 is roughly the size of this town in UK, it's Gloucester. The population is about 110,000. Worcester is about 93,000 and Bath is about 90,000. So that's really huge. So it's like a whole, the entire population of a town or a city, okay, being killed as a result of work in construction. So that's a huge number, okay. So that tells us that we certainly need to do something to improve the health and safety condition within construction. Okay, so now think about the next set of slides I'm going to show you. So what are your thoughts on these images? So what do you think about this site? Yeah, you don't need to respond, but just think about it. Okay. Is it a
Sure.
very clean? Yeah.
I think cherish life and stay away from construction.
Okay. Yeah. 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 Okay. Good. Yeah. Thanks. Yeah. But well. Yeah. So just think about it. Okay. Yeah. So you don't need to say anything or type anything, but yeah, but thanks for that anyway. So but clearly you can see that it's an untidy site. Okay. And an untidy site is a dangerous site. So that's also another interesting image about a construction. So you can see down there is very untidy, and people are working without fall protection, and down there is very dangerous. So should someone fall, they would be, they'll be in really bad state given how untidy the floor is. And some of the scaffold, it's probably not very stable. Okay. So and so what do you think would be the outcome of those images we saw? So this could be an outcome when things are not done safely. So that's the collapse of a tower crane, I think it's not a tower crane, mobile crane. So this I think it happened in Manchester where I live. So Manchester Evening News. Okay, I don't know what date that was, but it looks like it happened in Manchester. Okay. Maybe it did, yeah. And then let's move on to the next slide. Okay, so what do you think about this? So in the worst case, people can lose their lives, okay? So that tells us how dangerous the sector can be. In 2014, unfortunately, a worker died in the Crossrail Tunnel project that was being built in London. They finished the project now, so it's now the Elizabeth line. So the London Underground, they were building a new line, okay, and it's been completed. They call it the Elizabeth line. So they were hoping that there wouldn't be any death on that project, but unfortunately, one worker lost their life. Okay. So now let me ask you another quiz. So go to menti.com and then put in this code and then answer the quiz. You will see. So let just give me a second. I need to go and open that quiz. So I've paused sharing. Let me go there. Let me close this one. Let me get quiz number 2. So quiz number 2, where is it? Okay. Okay. So quiz number 2 is ready. Resume sharing. Yeah. So you can go there and answer. Okay, so we are 25 now. Okay, so let's try and get to. So the code is 83332872. Okay, I see people are completing it. Let's try and get to 20 quickly. Looking at my time. Or maybe if we get to, 15, I'll just, because of time. Let me go to myself, menti.com. Okay. So nearly there. So let me share. Let me show the results. Once again, the results has been a problem. Okay, let me stop. Let me exit the screen. Okay. Good. Okay, so 19 of you completed this. And here are the results. So one person said manual handling, another person said mechanical handling. 14 of you said untidy site. And then 3 of you said permanent works design. Okay. So we'll find out in a bit who got it correct here. Let's go back to our presentation. and then you'll find out as we go on. Okay. So the case to improve health and safety in construction, okay? But we'll come back to this at some point. Okay, so we've looked at the outcomes, okay? And now, but we need to improve health and safety in construction. So why do we need to do that? Okay, so because of, apart from the injuries and then the deaths and then the illnesses, there are also economic and social, there are costs, okay, that are associated with these injuries and deaths and illnesses. And these costs are borne by the employer, so that could be the contractor or the subcontractor. They are borne by governments through medical care, okay, providing medical care for people who get sick or get injured. They are borne by the workers themselves, so the employees, clients of the project, the whole industry, and then society as a whole. Okay, so the costs are spread across several stakeholders. Okay, and these costs can be very huge. So, for example, in the UK, the Health and Safety Executive, which is the equivalent of DOSH in Malaysia, so they estimated that it costs society about it costs about 1.3 billion pounds. Okay, health and safety, okay, cost 1.3 billion pounds. So the cost of injuries and illnesses in UK construction is about 1.3 billion pounds. So the injuries side is about 972 million. And then the health side of things, the illnesses is about 412 million pounds. Okay, so that's a huge amount of money. 1.3 billion pounds is a lot of money. A lot of money. So what can let's think about what we could do with 1.3 billion pounds. Okay, if somebody calls you today and they tell you, okay, you know what, you won a lottery and the amount is 1.3 billion pounds. So guess what you can do with that amount of money? So that's a lot of money. You could probably buy so many houses, okay, and then maybe sell them, okay, or do something. Okay. So what can we actually do with this 1.3 billion? So in the UK, when we did the London 2012 Olympics, this stadium, the Olympic Stadium, cost about 500 million pounds. That was around, as at the time, around the time they built it, okay? And then the Shard cost around 500 million pounds, okay, as at the time it was built or after the time they did that estimate. So you can imagine 1 billion pounds can get us one of this and one of that. Okay, so if we are able to drive down injuries and illnesses in construction, so that means that the industry or society will be saving this amount every year. That is in the UK here. So that means there's real need, okay, apart from preventing people from getting hurt and injured, there is the economic case to also reduce illnesses and accidents and injuries in construction. Okay. So a lot of and when we think about the cost of these accidents, okay, whereas it's easy to estimate the direct cost, some of the costs are very difficult to estimate. And so we may not actually know or fully appreciate the cost associated with accidents, okay? Yeah, in the workplace or accidents in construction. So there are other indirect costs that are associated with it, apart from the direct cost. And there are other intangible costs, okay, lowering the morale of the workers. If somebody gets hurt or somebody gets killed on the site, the morale, goes down because people, feel that definitely people know they've lost a friend or they've lost a colleague. And so that will dampen the morale of the workers, damage of the company's image. okay? So that it's hard to quantify in terms of money, but if a company's image is damaged, they may not get work to do, okay, again, or for a long time. So these are some of the costs associated with accidents in construction, okay? So the quiz 2 is still there, okay? But let me jump to this other quiz for you to do. We'll come back to the quizzes. Okay. But so now let's try this. Let's do this quiz, and then later on I'll come back to them. So let's go to quiz number 3. Let me pause sharing. Let me launch quiz number 3. I'll come back to the quizzes later. Let me get quiz number 3. Okay. Let me present quiz 3. Good. Let me resume. Okay. So with quiz 3, I want you to give me examples of causes of accident in construction. Okay. So that's the code over there. And give me some causes of accidents. So whatever you think is a cause of accident in construction, so you can type it in there. Okay. So whilst you do that, I will carry on. Okay, someone says trips and falls. Okay. So one person has responded. Okay, any more? Unsafe work condition, tripping hazard. Okay. Not using PPE properly, electrical hazard. Overconfidence. Okay, that's interesting. Unsafe acts. Okay, that's behavior. The mindset or the attitude of the of workers. Inadequate supervision. Okay. Foresight condition. Illegal command. Okay. I guess that means wrong instruction. So we have electrocution and electrical hazard. So all talking about electrical issues. Okay, yeah. So you've all given interesting, okay, or relevant courses, okay? So now let's look at how these courses have been reported in the literature based on accident studies people have done. Okay. So let me go back to my slides. We can come back to this later. But we'll come back to our second quiz at some point. Okay. So you gave examples of causes of accidents, okay, and those causes you gave are relevant, okay. And in literature, several studies have been done, okay, to understand what causes accidents. Because the idea is that if we know what the causes are, we stand a better chance to prevent them, okay. And so several studies have been done. So these are some of them. These were done in the UK, a team at Loughborough University, a team at the University of Manchester. It used to be UMIS then, and this is for my own PhD research. Okay. So they say that, so these people did some studies and then they propose a model of accident causation. They also propose a model and also propose a model. So the models of accident causation, they explain how accidents happen. They try to explain, okay, how accidents happen. So that based on those explanations, the idea is that we will probably then be able to to deal with them. Okay, I can see a red cross across the screen. Okay, I think it's gone now. Okay. Yes. Okay. Yeah. So VSuper proposed a model called the constraint response model. And what they meant by that model is that when delivering project, the project team, they face constraints. Okay. And as a result of those constraints, they respond. Okay. And so that process of constraint and responding to that constraint induces causes of accidents. So that is what they mean by the constraint response model. So for example, a constraint might be, let's say they are working in an area, so maybe the client doesn't have enough money, okay, to be able to build the project how it should have been built or how they wanted to build it. And so the design team or the construction team may have to respond in a way, okay, that they feel most appropriate to be able to address that constraint, okay? And in the process of doing that, that response and the constraint will then induce some causes of accidents. And then this model by these folks in Loughborough, so they call it the CONCA, the Construction Accident Causation Model. So they investigated, I think, 100 causes of 100 cases of accidents, and they posed their model. Okay, let me see if I can just hold on. Let me try and see if I can find the models. I think I have them somewhere here so that I can share them with you. Okay, good to see it. So I have them with me here. So I'll quickly talk through them to talk about them. So resume sharing. Okay, yeah. So this is the constraint response model. So they are saying that the physical and business environment will induce some project conception constraints, and then there will be response from the client. There'll be project management constraints coming from here, design constraints, and then the project management team and design team, they will respond. And when they respond, it induces construction management constraints. And then the construction management team will respond. That will induce subcontractor constraints, constructor response. So that process keeps ongoing, okay? And then they induce operative constraints, okay, and other constraints. And then they lead to inappropriate construction control, inappropriate construction operation, inappropriate operative action, inappropriate site condition, inappropriate construction planning, and then they lead to the accident. The one developed by the team at Loughborough, so they said that there are several groups or categories of causes. So they call them the underlying influences. So these are the root causes, okay? They call them the originating influences. They call this another group of causes shaping factors. And then there is an immediate accident circumstance. So they are saying that accidents occur as a result of the interaction between the work team, the workplace, equipment, and materials, okay? But the work team, workplace, equipment, and materials are also influenced by other factors. So for example, suitability or condition of the equipment, the layout of the site, the behaviors and capability and communication of the team, which are then also influenced by these. And then these also influenced by more underlying or distal factors, okay? And in terms of the distal factors, they say that what under project permanent works design. So design is an underlying cause of accident, is a root cause of accident. Design can affect these other factors, and then these other factors will then affect these, okay, and then lead to the accident, okay. So that brings me to the quiz that I think that was quiz number 2. So let's see those of you who got that quiz correct. Okay. Yeah. So 14 of you said untidy site. Only 3 of you said permanent works design. So that is a correct answer. So from the model, we can see that permanent works design, in other words, how a building has been designed, okay, how the permanent works have been designed is a root cause of accident, is an underlying cause of accident. Okay, these other ones are immediate causes, or they are proximate causes, because they are more closer to the occurrence of the accident. But these ones are further away, okay, in the causation process. Yeah. So those of you who said permanent work design, so that's the correct answer. So manual handling, mechanical handling, untidy site, these we call them proximate causes, okay? Or they are because they are more closer to the occurrence of the accident than other causes like the permanent works design or design, okay? So let me go back to my slide. Okay. Okay, so quickly. Oh, looks like I have some few minutes left to cover this with you. Okay. Okay, so repeat. Okay. Yeah, so these are some causes of accidents from the studies that the people in Loughborough did. You can see that workers' behavior, they found out that workers' behavior contributed to almost half of the accidents they investigated. So worker behavior is a key contributor to accidents, okay? And they also realized that design contributed to about 30%, about 1/3 of all the accidents they investigated. So that's also a significant one, okay? So clearly, and then the study, my own research that I did showed that complex design has a high potential to influence the occurrence of accidents. Another study that was done in the US, they investigated 224 fatal accidents, and they were able to find out that for 42% of them, there was some link to how the design of the building or the structure was done, okay? So there's a lot of studies that demonstrate the link between design and accident. So this is another study that was done in Australia. So they traced, okay, back to design, okay, as to show that design is a contributor to the occurrence of the accident they investigate. So they investigated 256 cases of occupational death in Australia, and they traced back. They wanted to see what the underlying causes were, and design was one of them. Okay, as we can see, permanent design. Okay. Okay. So which stage? So based on what we've done, which stage of the construction project life cycle offers the greatest opportunity or ability to influence safety? So quickly, let's go to menti.com. I'm going to launch it because I'm conscious of time now. So that's quiz 4. So I want you to tell me what you think. So that's quiz number 4. Let me launch it. Present. Okay. So which of these stages gives, the code is 85120824. So which of these stages gives the best opportunity or ability to influence safety on construction site? Okay. So keep answering that. So let me put the code in the chat so that we can carry on. So the code is that. That's question 4. That's the code. Okay. Okay. Okay, I need to see. Let's get the responses because the next slide will give the answer. So let's okay, because of time, let's show what people have done. I have 16 of you, that's 17 of you. That's not bad. Okay, quickly. Let's say, okay, good. So that's really encouraging. Okay, yeah. So 13 of you say that the design stage gives the best opportunity to influence safety. And that is absolutely correct. Okay, so let's go back to our slides. So some of you may have come across this time safety influence curve. Okay, and what it suggests, what it's saying is that the earlier phases of projects give us the best ability to influence safety. So as we progress from the design to construction to the close of the project or to handover, that ability to influence safety goes down. And the same can be said of other things like cost. Okay, so our ability to influence cost on a project is greatest at the start. Okay, once you start doing designs and you get into construction, it becomes more expensive to influence cost, because if you do a change in the design, the cost might be very, very high. Okay, so the same way, our ability to influence safety is greatest at the design stage. Okay, and that is where the concept of design for health and safety comes in. So design for occupational safety and health. Okay, because the design phase gives us the best opportunity, it means that designers, clients, and other members of the project team need to do their best, okay, at that stage, okay, to be able to influence safety. Yes, someone else asked for the slides. Yes, I'm going to make the slides available. Okay, I'll send it to Dr. Maslina, and then she will make them available to you. Okay. Okay, so let's move on quickly. So, and again, so the concept of design for safety, it also is aligned to the hierarchy of risk control. So in safety and health, there is this concept of hierarchy of control. And the hierarchy of control simply says that we should do our best to eliminate hazards. So that should be the first thing we need to do. So when dealing with health and safety risk or hazards, our first priority should be to eliminate or substitute the hazard. And if that is not possible, then we need to think about other things like reducing or limiting exposure to the hazard, isolating people or segregating people from the hazard. So if we cannot take the hazard away, let us limit or reduce exposure. If we can't do that, then let's segregate people from the hazards. Or we can bring about engineering controls, safe systems of work, provide training, and PPE. So PPE should be the last resort. But sometimes on construction site, the first thing people think about is to give PPE to people. No, so PPE should not be the first thing we think about. The first thing to think about in dealing with safety and health issues is to remove the hazard in the first place or to substitute the hazard. Okay, so the design for health and safety concept, okay, is aligned to the hierarchy of control. So when we do design for safety, the idea is that we are removing the hazards by designing out the hazards. So for example, if it's a tall building, it's a multi-story building, is it possible for us to design it such that there will not be the need for people to work at height? So for example, we can design it to use pre-assembly, design for manufacturing assembly, okay, or modern methods of construction. So where some components are prefabricated on site and they are brought and then installed so that people will not have to work at height. Okay, so that is what the concept of design for safety is about. So planning and design, most important stage to influence health and safety. Okay, and there are some case studies to demonstrate that. Okay, but because of time, I will not go through all of them, but I'll just show you one example. But when you get the slides, you can look at them. So one example is this. So it shows, so this example shows what designers can do by providing hazard symbols on drawings. So when designers prepare their drawing, these days it's easy to do that with BIM. So they can put some symbols, okay, on the drawing to alert the construction team for them to know that these hazards are available, okay, are present in these places, okay, of the project or of the design, okay. Let me quickly show you another example. So I think probably this one, yeah, will be better. So what designers can do, okay. Okay. So this is a case where they've tried to put some balustrades, okay, in it as they are building so that people, don't fall during construction. I think maybe this will probably be, yeah, so yeah, this one is better. Okay. Yeah, okay. So to prevent people from falling, through the roof where they have, light glass, in the roof, so they can design it to have some mesh protection, or they can have some, balustrade railing, okay, over there, or they can put it around, okay, wherever that glass is in the roof to prevent people, from falling when they are doing maintenance work or other things, okay. Okay. So quickly, I'm almost done. Okay, yeah. So design for safety. So what are the factors that influence implementation of design for safety in construction? So several factors. So attitude of designers, awareness and knowledge and education of designers. So the availability of tools to help designers to do design for safety, and the influence of clients is very important. And then legislation. So these are things that affect or influence implementation of design for safety in the construction industry. And talking about regulation, some countries recognizing the importance of design for safety have introduced regulations to make designers think and assess the risks associated with their designs, and then for them to implement things to remove those risks or to inform contractors about those risks. So in Australia, they have this regulation. In UK, we have the CDM. In Singapore, and then in Malaysia this year, they introduced Occupational Safety and Health Construction Work Design and Management Regulation, which draws heavily on the UK version of that regulation. Okay, so the whole idea is that these regulations, they place legal duties on key people or key organizations. So that UK one places a duty on the client, on designers, on contractors, on the workers, principal contractors, that is where there are multiple contractors on a project, or principal designers, if the project meets some criteria, they need to appoint a principal designer, okay, and all of them have duties and responsibilities, okay, under the regulation to ensure that designs, okay, are done, prepared, or modified in a way that they are safe for people to build or construct them, okay, and then the others also have various duties and regulations, various duties, okay, under those regulations. And in terms of tools, so various research has been done, okay, to provide tools to help designers to do that. So this is a tool from a recent project I was involved in. It's called the BIM Risk Library. It helps designers, okay, to identify hazards, and then it helps designers to think about what measures they can introduce in the design to deal with those hazards. And this is a project that I led. I developed a tool to assess how competent design companies are to implement design for safety, and there are other materials to help designers to implement design for safety. And let me emphasize that in Malaysia, UITM, is one of the known universities for design for safety research and training. So Professor Khairul, Sheila, and Mazilina, they do a lot of research, okay, and industry engagement in design for safety in construction, okay, in Malaysia. So if you want to know more about it, I'll say that you are in the right place and you have the right contact with you to help you to learn more about design for safety in construction. And there are some industry groups in the UK that are helping to promote design for safety. These are some of the examples. In Malaysia, there may be similar groups there to enhance, the awareness of design for safety in Malaysia. Okay. And for my final quiz before I go, so go to menti.com, put this there, and then respond to this last quiz as we end our lecture. So let me go there. So quiz number 5, so quickly, and then we are done. So quiz number 5 is here. Okay, so let me launch the quiz. Present. Okay. So who is responsible for health and safety of workers on construction projects? Who do you think is responsible? Okay, so tell me what you think quickly. And then whilst you answer them, if there are any questions or if anybody has a question, so this is the time to ask, please. So any question, please feel free to ask. Okay. So here are the results. Okay, so this is the correct answer. So all of the above. Okay, so health and safety is a responsibility of everyone on the project. So the client, the designer, the contractor, the workers. So health and safety is not just the responsibility of designers or contractor or worker, but it's everybody's responsibility. Okay. And then I think let me present, the results for quiz 4. I'm not sure we looked at that one. Let me see if, so quiz 4, what was the result for that one? Okay, I think we looked at it already. Okay, yeah, we looked at it already. So it's the design phase. Which stage of the construction life cycle offers the greatest ability? So that's the design stage. Okay, so 15 of you said the design stage, so that's the correct answer. Okay, let me present it. So that's the correct answer, design stage. Okay, so we talked about it already. So I think that brings me to the end of my lecture. Okay, so if there are any questions, so please, this is the best time to ask them if there are any questions. So let me pause sharing. And then I see that Anderson has a question. So Anderson, yeah, please, you can ask.
Yes, doctor. Do we have standardized tool wherein we can use anywhere globally to assess risk, especially
Oh,
in construction?
okay. Just give me a second. You mean standardized to, wait, let me stop. I don't need to share. Let me stop sharing. Just give me a second. Yeah. So why do I stop sharing now? Stop sharing. Yeah. Okay, good. Yeah. So you're asking about standardized tools. Yeah. Well, yeah, I think, yeah, several tools have been developed, okay, which I think, regardless of the country, you can still apply them. But But if there are tools that have been developed, okay, based on data or insights from a particular region, I think it makes sense to use those ones, okay, because they've been informed, okay, by data or insights, okay, that are pertinent to that particular region, okay. But of course, nothing stops you from, using other tools that have been developed from other parts of the world. So, for example, let me show you, on my screen, the tool I was talking about from, let me show you that one. It's called the BIM Risk Library tool. Let me quickly show you. It's a video, but you can watch the video later on. Just give me a second. Okay, let me quickly. Okay, so let me share my screen and then I'll share screen. That one, share audio. How do I I want to include the audio. Share sound. Yeah, good. Yeah. So this is the project that I was referring to. It's called the BIM Risk Library. Okay. Yeah, so we developed this tool from research project we did in the UK here. Okay, and so what the tool does is that, so you have a BIM model, and then you go in the BIM model, and then you highlight a place where you think where there is a hazard. Okay, and then the tool then enables you to indicate. Okay, so you can assess the level of risk. Okay, and then the tool enables you to indicate what solution or what measure you want to apply or implement, okay, to be able to deal with that risk, okay. But the data that informed this tool was based on accident data from the UK. So we worked with the health and safety executive, the equivalent of DOSH, and we used data they provided, okay, to inform the development of that tool, okay. And also we then engaged with industry professionals for them to tell us how best to deal with those risks. So there were several risks, but for this project, I think we focus on fall from open edge or something, okay. And so there were several should I say, scenarios that could lead to that. And so for those several scenarios, we worked with the professionals for them to tell us how to address each of them, okay, throughout the project process, from early design, what can you do to address it, from maybe detailed design, what can you do to address it, when you move to the construction phase, what can be done to address that. So for such a tool, you could still use it in Malaysia, okay, if you feel that the content or the insights that have been used to create it, are still relevant for that context, which I think they are. Okay, so nothing stops you from, using tools, that have been developed from other parts of the world. But certainly, if a tool has been developed with data or insights from a particular region, that I think will be can be very helpful. Okay. Yeah, but when I give you the slides, you can take a look at the video. It tells you a bit more about how the tool works, and then if you want to get a copy of it, I think you can. It's called Safety Base. Okay, so you can go online and then you can search for it, and then you can contact them. Okay, to see if you think your company will be useful for a company to have that tool. Okay. Okay, so let me stop sharing. And I think, I see another hand is up. Yeah, hey, Wei, I think your hand is up.
Yes, doctor. Good afternoon. Dr. Patrick. I know the design accident as a primary factor in construction site. So what can be done to avoid casualties from technical design accident in the United Kingdom? In China, construction engineers or structural engineers will add conservative safety factors to avoid the risk of design accident. So I want to some about technical factors in Britain. Thank you, doctor. And another question, can you show us some safety slogans on British construction site through picture or videos? Thank you, doctor.
Yeah. Can you ask the second question again? I didn't find. Can you repeat the second question?
Oh, okay, doctor. Could you show us some safety slogans on
Okay.
British construction site through picture or video? Because I think maybe perhaps some culture different.
Okay. Yeah.
It's
Oh, okay. Oh, no,
interesting.
no, no, okay. So you mean slogans, safety slogans?
Yeah,
Oh,
doctor.
okay. Oh, okay. Okay. Well. I'm. I know a few. But I don't know if. Uh. I'm not. I don't know a lot of such slogans. Yeah. But I think yeah, these are things you could just search online, maybe health and safety slogans or symbols. Okay. Maybe construction health and safety symbols or slogans. Okay. Yes, and you can find them. But the slides that I would send to you, so that the slides have some very good links to materials that are based in the based on practice design for safety practice within the UK. Okay. So maybe let me share my screen again, and then maybe I'll respond to your other questions. Okay. Okay. So the links in the slides are very good. So this one is a very good one. This one particularly for design for safety. Okay. So this website, so a group of I don't know, I think they are, I don't know whether they are some people. Oh, come on. No. I don't want annotation close. Let me put it here. Yeah. I find it to be very useful. It's called Design Best Practice for Designers. Okay. And it's been done by professionals in industry. So what they do is that they, they they've they've put case studies. Okay. Case studies of how to do design for safety regarding architectural design, civil, structural, mechanical, electrical. Okay. So if I pick, let's say, architecture, so these are case studies that have been put there, and these are the companies that provided those, and the people who provided those case studies. Okay. So for example, it says what? External refurbishment of an unusual structure, plasterboard. Okay. Prefabrication and offsite manufacture case study. So let's, for example, look at this one. Okay. So you can then click on it. So that was put there in 2015. So that was a long time, some time ago. So it tells you what the challenge or the problem was, what the risk was, what solution they proposed or they did, what the benefits were or was. Okay. So this resource is a very good one, particularly for design for safety. Okay. So I'll encourage those of you who are into that, okay, or if you know colleagues or design practices, that are trying to improve their design for safety implementation. So this is a very good resource they can use. And then this other one is from the US. So this is also very good one. It has several materials about that. So if you go there, okay. So they have things about some relevant publication tools. So you're talking about tools, processes, okay? So if you go to the tools, for example, there are several tools they've suggested, okay, that can help. Okay, yeah, so that's what I will say. So these links will be very helpful, okay, for you. And this is a tool I developed myself. That's a BIMRIX library tool, okay. Yeah, and then, but in response to your first question, you talked about factor of safety, okay. Yeah, so the factor of safety is also done by structural designers in the UK, okay. And I remember when I studied for my undergraduate, I did reinforced concrete design, I did structural steel design, and as part of that, you need to incorporate factor of safety. Okay, so for example, if the load is supposed to be, if the load will be maybe, I don't know, maybe 5 kilonewtons per millimeter squared, okay, or whatever it is, the factor of safety will increase that load so that you design to take into account sort of like a worst case scenario, okay, here. So those practices are there, but design for safety talks about protecting the workers who are building the building, okay? So the factor of safety is to ensure that the building will not collapse after it's been built, okay? So you are building into it some more strength, if you like, okay? But design for safety, you are thinking about, so the people who are going to build a building, the process of building it, okay, how the designs have been done can pose risk. So what can I do to reduce that risk from them by designing out hazards? Okay, so for example, if you design and you specify hazardous material, most likely people can get hurt or they can fall sick because they are using very hazardous material. So if you've designed and you specified, let's say, asbestos, okay, and people are using the asbestos and then it falls down and then it's, the particles get into the atmosphere, people can breathe them and then they can fall sick. Okay, so design for safety is about protecting the safety and the health of the workers who will build the designs, as well as protecting the health and safety of the workers who will be involved in maintaining the buildings. For example, if you've designed and you've designed such that maybe they will need to use ladders, okay, or something to be able to change the light bulb or clean the building, that poses risk for the people who will maintain the building. Okay, but if you think about, okay, how can I design so that I can reduce the likelihood or the risk involved for the people who maintain the building or maintain the assets? Okay, so that is what the concept of design for safety is about. It's not just about the factor of safety, but it's about protecting. So for example, this one, okay, so you've designed to include a rail around this item so that people will not go close to it and then fall down through it. So for example, you've designed it and you've included some railing at the edge of the roof. Okay, so that when people are up there working, they will not fall over. Or you've designed to include this mesh over this space in the roof so that workers, when working up there, will not fall through it. Okay, so that is what we mean by the design for safety and health in construction.
Thank Dr. Essie. I have already shared screen. Thank you so much.
Okay,
Yeah.
okay, no worries. Yeah, but
Can I?
but I'm going to share the slides. Okay, so you can have you have the slides later on. Okay, yeah.
Mm,
So
I
let
want
me
to ask
stop
one
sharing.
question from the
Oh,
photo. Okay.
okay.
Normally for our construction, the temporary work is designed by the contractor after they got the design. So from this topic today, I believe the designer need to include in their original design for the temporary work design, is it?
So in UK too, we have temporary works designers. Okay, it's people who specialize in designing that. Okay, so in the same way, they will also need to think about how their designs, okay, can cause harm, okay, to workers and try to mitigate those risks posed by the design of the temporary works. Okay, yeah, but with design for safety, that the focus tends to be on the permanent works design. So the final building, okay, or the final bridge or whatever. Okay, so how it's been designed. So are there any things about the design, other than materials, okay, specification, or maybe the shape or something that can pose risk to the workers? Okay, then they try to mitigate those risks, okay, by either designing them out, or they can uh, or they can highlight those risks to the contractors for the contractors to be aware of them, okay, and then be able to put in place things, to be able to address them. Because sometimes it's not everything designers may be able to address, okay, but as part of design for safety, the designers will then need to make the contractors aware of those residual risks in the design so that they can implement things during the construction phase to be able to deal with them. Okay, so design for safety is not just designers trying to do something, but it's about designers, okay, and contractors and other people working together to be able to make sure that the construction site is safe, okay, for workers to work there. And you can see from one of the oh, I think I've removed it. Let me show that slide again. I wanted to show you one comment. Oh, the examples I showed you. Yeah. So the one that has the hazard identification drawings. Let me show you that one again. Okay. Yeah. So this example. So in the past, for example, in the UK in the past, when the drawings were 2D drawings. Okay, it's these days we have BIM and other things. Okay, so the idea of the hazard identification drawing was that contractors use drawings to build. Okay, and they would always read drawings. Okay, so is there a way for the designers to highlight on the drawings where hazards are? Okay, so that the contractors can be aware of those hazards in the drawing. Okay, so if a designer is unable to address a hazard by changing the design or modifying the design or introducing a design solution, what they can then do is to notify the contractor, okay, of such hazards, so that when the contractor comes on board, they can also then implement the appropriate measures to deal with those hazards. Okay, but these days we have BIM. So in BIM, it's not a 2D representation, a 3D representation. So in BIM, these days the designers are able to highlight those parts of the design in the BIM model where those hazards are, and that is where this and that is how this tool works. So in the BIM model, so this is a BIM model, and they've put this sign there to show that there is a hazard over here. And so when they click on it,
quickly assign it to
so when they click on it, the information about that hazard will appear, okay, including maybe how to mitigate that, to deal with that hazard. Okay.
Okay, Doctor.
Yeah. Okay. Yeah. Is there any questions? I'm conscious of time.
Any question, guys? I think one more question, Dr. Patrick, in message.
Okay.
Can
Okay.
I read? Okay, how does in the UK implement design for safety in the construction sector? Is it the same designer or do we need to appoint a safety specialist to provide input during the design process?
Okay. Yeah. So I'll say that it's the same way as it's done, in Malaysia under the OSHIM, and then now the new regulation. Okay. So as I said, in the UK, under the UK regulation, so the designer has a responsibility. Okay. So all designers, so civil designer, structures, mechanical. So every designer, so long as you are appointed a designer on the project, okay, you have that legal responsibility. Okay. And that legal responsibility says that, let me read it to you. Okay. So the designers are organization or individual preparing or modifying designs for construction work or arranging for or instructing others to do it. Designs include drawing, design detail specification, design calculations, bill of quantities. Okay, so anybody, either you are modifying, whether you are an organization or an individual, whether you are preparing, whether you are the one modifying it, okay, or you are the one instructing others to do it, okay, so the legal duty to think about health and safety falls on you. Okay, so let me read the question again. How does the UK implement health and safety? Is it the designer or do we need to appoint? No, yeah, so it's the designer who does it, not a specialist, not a safety specialist. Okay, but some design companies have safety specialists employed within them to help the designers. Okay, but the responsibility is not the safety specialist. The responsibility lies with the designer. Okay, and so that is why in UITM, so in Malaysia, I think UITM is one of the DOSH approved centers for design for safety training, for prevention through design training. Okay, so I know that Dr. Mazlina, Kyril, and Sheila, I believe they've been doing OSHIM training, in this area, okay, for designers and other people. So the responsibility is for the designer. But the designer, if you are not experienced in health and safety, what they do is that they employ safety specialists to help them, to advise them. Okay, but the legal responsibility rests with the designer, not the safety specialist. Okay. Yep. Okay, so any more questions?
Any question? We are actually has more than half an hour. Sorry, Dr. Patrick. So a lot of question for them, but
That's fine.
new knowledge. Thank you very much. Okay, I think no more question. Okay, thank you very much, Dr. Patrick. At least we know the site construction in global perspective. Okay, thank you very much. So before we end our session, can we take a picture? Okay, can you
Yes, it's
open
fine.
the
Yeah.
camera? Okay. Okay, ready all? Okay, 1, 2, 3. Okay, wait, I need to paste it first in group. Okay, I think one more time. Okay, ready guys? Okay, 1, 2, 3. All right. Okay. All right, I think for tonight, the slide Dr. Patrick will share with the Dr. Lina, and then we share on you in your WhatsApp group. Okay, guys, thank you very much for tonight. See you on the next week. Okay. Okay, thank you
Okay.
very much.
Yeah,
Dr.
thanks
Patrick.
very much.
Bye-bye.
Bye-bye then. Bye.
Thank you. Okay.
Thank you, Dr.
Bye.
Patrick.
Thank you.
Bye.
Thank you, Doctor.
Okay, guys. Dr. Patrick dah keluar kan?
Yes, yes.
Okay, alright. So, hope you get some knowledge lah, okay, from both lecture, okay, from the guest lecture. And next week, we start at 7, okay, 7 until 8, and then 9 to 10. Okay, we start class at 7, and some of them not yet take your attendance at your future, please. Alright, and then we have another one guest lecture, and then the following weeks is test, right? So you have another one week more, alright, before the final test. Alright, okay, guys.
Okay, doctor.
Okay,
Doctor.
yes, okay. Alright, thank you very much. Bye.
Thank you, doctor. Bye.
Thank you, Doctor.
Thank you, Doctor. See
Thank you
you
so
around.
much, Doctor. Bye, Doctor. Bye-bye.
Bye. Ronok yang habis lawan.